Betelgeuse, an enormous red supergiant star situated in the Orion constellation, has intrigued humanity for many centuries with its rich crimson glow and colossal dimensions. Astronomers estimate that if Betelgeuse were placed at the center of our solar system, it would consume every planet up to Jupiter. This star is so massive that it symbolizes the final phase of evolution for stars like it, poised to culminate in a spectacular explosion, a supernova. In recent years, Betelgeuse has started to show strange behavior. 34 seconds. In a surprising twist, its brightness surged by over 50%, pushing it from the 10th brightest star to the 7th in the night sky. This sudden increase in luminosity left scientists scrambling to find an explanation. Was this the beginning of its catastrophic end, or merely a temporary anomaly in its life cycle? The consequences of Betelgeuse undergoing a supernova would be enormous. It could transform night into day, offering unmatched opportunities for scientific discovery. A star's luminosity is influenced by factors such as size, temperature, and its distance from Earth. 1 minute and 9 seconds. Betelgeuse, which has a radius more than 700 times that of our Sun, is relatively cool, with surface temperatures ranging between 3,000 and 3,500 Kelvin. This coolness gives it its distinctive red color. Despite its immense size, Betelgeuse's cooler temperature makes it a prime candidate for a supernova, which is why its recent behavior has captured such keen interest. In late 2019, Betelgeuse astonished astronomers once more by dimming to just 40% of its usual brightness. This phenomenon, visible even to the naked eye, sparked a wave of observation and debate. Some speculated that the dimming was caused by dust blocking the star's light, while others believed internal processes were at play. The idea of an impending supernova became the focal point of discussions. 1 minute and 45 seconds. Utilizing the Very Large Telescope, VLT, in Chile, astronomers were able to capture detailed images of Betelgeuse during its dimming phase. These images revealed that the star had developed a distinctively lopsided appearance. Further investigation showed that the dimming was likely due to a massive surface mass ejection, SME, during which Betelgeuse expelled a tremendous amount of material into space. This extraordinary event reshaped the star and disrupted its pulsation cycle. The SME was akin to a volcanic eruption on a cosmic scale, with Betelgeuse releasing 400 billion tons of material, 400 times more than a typical solar event would produce. This upheaval not only changed the star's appearance but also shortened its pulsation period from 400 days to just 200 days. These dramatic changes indicate that Betelgeuse is becoming increasingly unstable, raising the question: how much longer can it maintain its current state? 2 minutes and 53 seconds. The recent developments in Betelgeuse's behavior have prompted astronomers to intensify their observations, searching for further signs of its impending collapse. When a massive star like Betelgeuse exhausts its nuclear fuel, its core collapses under the force of gravity, triggering a supernova. This explosion releases an immense amount of energy, ejecting the star's outer layers into space and creating a dazzling light show that could be visible even during the day. If Betelgeuse were to explode, the first sign would be a surge of neutrinos, subatomic particles that travel close to the speed of light and can escape from the star's core. These neutrinos would reach Earth hours before the light of the explosion. Once the light does reach us, Betelgeuse would shine brighter than the full moon, casting shadows and turning night into day for weeks. A supernova of Betelgeuse's magnitude would provide scientists with an unparalleled opportunity to study stellar death in real time. By analyzing the light, heat, and radiation emitted during the explosion, researchers could gain valuable insights into stellar evolution, nuclear physics, and the formation of the elements that make up planets and life itself. 4 minutes and 29 seconds. To understand Betelgeuse's behavior, scientists are using advanced simulations to model the star's interior. These virtual models incorporate data from telescopes such as the James Webb Space Telescope, JWST, and the VLT, allowing researchers to investigate the processes that drive Betelgeuse's instability. These simulations suggest that a massive gas bubble may have risen from deep within the star, triggering the SME and altering its pulsation rhythm. The JWST has also provided a closer look at the material ejected by Betelgeuse, revealing complex structures of gas and dust surrounding the star. These observations point to the possibility that Betelgeuse may be entering its final stages, offering an unprecedented glimpse into the life cycle of a massive star. 5 minutes and 1 second. While scientists estimate that Betelgeuse could go supernova within the next 10,000 to 100,000 years, its erratic behavior suggests that this timeline may be much shorter. The astronomical community is working tirelessly to capture every detail of this cosmic drama before it reaches its dramatic conclusion. In late 2023, the JWST focused its extraordinary capabilities on Betelgeuse, uncovering a startling phenomenon. Scientists discovered that, already unstable from its massive surface mass ejection, the star had experienced a rapid internal collapse. 6 minutes and 8 seconds. Astronomers observed dramatic fluctuations in Betelgeuse's pulsation cycles. Before the collapse, the star's surface expanded and contracted steadily over 400 days. Afterward, this rhythm abruptly changed to a 200-day cycle, signaling a massive disruption in the star's internal structure. This irregularity is akin to a cosmic heartbeat, suggesting that Betelgeuse is nearing the end of its stellar life. Simulations created by astrophysicists revealed that Betelgeuse's core was becoming increasingly unstable as it fused heavier elements. When stars reach this stage, they begin producing iron, a process that marks the final phase before collapse. Unlike other elements, iron does not release energy when fused, creating a buildup of mass that forces the core toward an inevitable implosion. 7 minutes and 12 seconds. Scientists are closely monitoring Betelgeuse for any sudden surge in neutrino activity. Instruments around the world are on high alert, prepared to detect this fleeting signal that could provide humanity with its first real-time warning of a supernova. While Betelgeuse's supernova will undoubtedly be an awe-inspiring celestial event, visible even during the day, scientists assure us that it poses no danger to Earth. However, its brightness could rival that of the full moon, casting eerie shadows and lighting up the night for weeks. 9 minutes and 19 seconds. The story of Betelgeuse reminds us that the universe is full of mysteries waiting to be unraveled. This colossal star, which has fascinated humanity for centuries, now challenges everything we know about stellar evolution and cosmic dynamics. Its potential to go supernova offers scientists an unparalleled opportunity to study the life cycle of massive stars in real time. Understanding these processes is crucial not only for unraveling the fate of one star, but also for unlocking the mechanics that shape galaxies, seed the universe with essential elements, and even make life possible. The tools we use to study Betelgeuse, from ground-based observatories like the VLT to cutting-edge instruments like the JWST, have opened windows into the universe that past generations could only dream of. 14 minutes and 55 seconds. What do you think will happen to Betelgeuse? Are we witnessing the final moments of a star about to explode, or is it simply another phase in its mysterious life? Share your thoughts in the comments and join the conversation about one of the most fascinating stars in the universe. Don't forget to like, subscribe, and turn on notifications for more cosmic stories that will blow your mind. Until next time, keep your eyes on the sky. For centuries, astronomers have speculated about Betelgeuse's inevitable fate, but on one fateful night, the universe finally answers. At first, it seems like any other night. Stars twinkle in the sky, and Orion stands tall in the heavens. But then, something extraordinary happens. A surge of neutrinos races through space, reaching Earth before anyone sees the explosion. Deep underground, neutrino detectors in Japan, the United States, and Europe register an unprecedented spike. Scientists barely have time to react before the night sky is forever changed. 16 minutes and 2 seconds. A burst of light unlike anything seen before erupts from Betelgeuse. For a moment, it is as if a second sun has appeared in the sky. The explosion is so powerful that night is turned into day across much of the planet. Shadows stretch across cities, and astronomers worldwide rush to their telescopes, knowing they are witnessing history. Betelgeuse has gone supernova. 16 minutes and 45 seconds. The shockwave from the explosion ripples through the interstellar medium, sending waves of cosmic energy outward. Telescopes like the JWST and the Hubble Space Telescope capture breathtaking images of the unfolding catastrophe. The supernova's core collapses in on itself, forming either a neutron star or, if the mass is great enough, a black hole. Back on Earth, scientists work around the clock to analyze the data. Spectral analysis reveals the formation of heavy elements, iron, gold, and even uranium, being forged in the heart of the explosion. This single event provides humanity with more information about stellar death than centuries of prior observation. 18 minutes. 4 weeks, Betelgeuse outshines every other celestial object in the night sky except for the moon. Its light bathes the landscape in an eerie glow, allowing people to read outside at midnight. Social media is flooded with photos and videos of the incredible event. Some cultures interpret it as a divine sign, while scientists marvel at the sheer power of the universe. As the weeks pass, the light slowly begins to fade. The once mighty star shrinks into a glowing remnant, surrounded by a newly formed nebula of gas and dust. Over thousands of years, this debris will scatter across space, seeding new generations of stars and planets. 20 minutes and 45 seconds. Astronomers, philosophers, and everyday stargazers alike ponder the significance of what they have witnessed. Betelgeuse's explosion is more than just a celestial event. It is a reminder that the universe is alive, constantly evolving. The data gathered from this supernova will shape our understanding of stellar evolution for generations. Humanity has not only witnessed the death of a star but also gained a deeper appreciation for how the universe recycles its materials, turning the remnants of old stars into the building blocks of new worlds, including, perhaps, future planets teeming with life. And so, the mighty Betelgeuse, which has captivated human imagination for centuries, leaves behind a legacy that will outlast its light. As astronomers turn their attention to other dying stars scattered across the cosmos, one question lingers: which star will be next? As the weeks turn into months, the once blazing beacon of Betelgeuse begins to dim. Its supernova, which had outshined the full moon, slowly fades into a glowing remnant. What remains is an expanding cloud of gas and dust, illuminated by the energy still radiating from the explosion. This new nebula, born from the destruction of a dying star, will linger for thousands of years, a cosmic monument to Betelgeuse's final moments. 23 minutes and 10 seconds, searching for the core. Astronomers focus their efforts on what remains at the heart of the explosion. The collapse of Betelgeuse's core has left behind one of two possibilities: a neutron star or a black hole. If the mass was below a critical threshold, the core would have compressed into a dense neutron star, an object no larger than a city but with more mass than the Sun. However, if Betelgeuse was massive enough, the core may have collapsed entirely, creating a black hole, an invisible scar in space where gravity is so intense that nothing, not even light, can escape. Scientists eagerly await the first X-ray and radio signals from the core region. If a neutron star remains, it may pulse rhythmically, sending out beams of energy, a new pulsar born from the ashes of Betelgeuse. If no such signals appear, it would suggest that a black hole has formed, swallowing all light and matter that comes too close. 25 minutes and 45 seconds. The ripple effect. The explosion of Betelgeuse sends shockwaves through the cosmos. These waves of energy travel at immense speeds, colliding with the surrounding interstellar medium. Telescopes detect the formation of shock fronts, regions where gas is compressed and heated to extreme temperatures. As these waves travel outward, they carry with them the raw materials for future star systems: carbon, oxygen, iron, and other elements essential for the formation of planets and even life. On Earth, astrophysicists analyze the neutrino data recorded in the hours before the explosion. These elusive particles, which passed through the planet before the light from the supernova arrived, offer a rare insight into the inner workings of a collapsing star. Their behavior provides critical information about the final nuclear reactions that took place within Betelgeuse moments before its death. 30 minutes and 12 seconds. A nebula is born. Over time, the remnants of Betelgeuse will continue to expand, forming a spectacular nebula visible across the cosmos. This glowing cloud, rich with elements forged in the star's fiery death, will serve as a nursery for future generations of stars. Perhaps, millions of years from now, new planets will coalesce from this very dust, carrying within them the echoes of Betelgeuse's legacy. On Earth, the event transforms our understanding of stellar life cycles. Scientists use the data gathered from the explosion to refine their models, improving predictions about other supernova candidates. The next great stellar explosion may not occur for centuries, or it may be just around the corner. 35 minutes. The cultural impact. Betelgeuse's supernova leaves a profound impact on humanity. Artists, poets, and writers find inspiration in its cosmic beauty. Cultures around the world assign new myths and meanings to the event, seeing it as a celestial omen or a symbol of rebirth. Religious and philosophical discussions emerge about the nature of impermanence. Just as stars are born and die, so too does everything in the universe. The explosion of Betelgeuse reminds humanity of its place in the grand cosmic cycle, a fleeting but meaningful existence in an ever-changing universe. 1 hour, the search for the next supernova. With Betelgeuse now part of history, astronomers turn their eyes to the next candidates for a supernova. Other red supergiants, like Antares in the constellation Scorpius, are monitored closely. New observational campaigns are launched to track changes in their brightness, pulsations, and internal dynamics. The tools used to study Betelgeuse's explosion, advanced telescopes, neutrino detectors, and space-based observatories, are now employed in the search for other dying stars. The question remains, which star will be next? As humanity continues its exploration of the cosmos, one thing is certain: Betelgeuse's explosion was not the end, but a new beginning in our quest to understand the universe.